Good evening, sir. My name is Geeta Mahalakshmi. Today I want to discuss about minimum edit distance in natural language processing. In natural language processing, minimum edit distance is also known as Leveshtein distance, is a metric for measuring how dissimilar two strings, such as sequence of characters or words, are by counting the minimum number of single character edits required to transform one string to another. There are certain operations performing in minimum edit distance or insertion, deletion, substitution. In insertion, he is used to adding a character. Deletion is used to removing a character, and substitution is used to replace one character with another. For example, let us consider two strings such as kitten and sitting. In kitten, substitute k with s, then it tends to sitten. Substitute e with I, it tends to sittin. Insert g at the end, it tends to sitting. Uh, the minimum distance between kitten and sitting is 3. We have to use certain operations like two substitutions and one insertion. Applications in NLP. There are different types of applications we are used in minimum distance, like spell checking, mission translation, information retrieval, text similarity. In spell checking, identifying missimilar words and suggestions correction. Mission translation is used to compare predicted translation with reference translations. Information retrieval is used to matching user queries to document with a slight variation in wording. Text summarization is used to measuring how close two pieces of the text are in terms of edit, useful in plagiarism detection or paraphrasing analysis. Algorithm. The algorithm used in minimum edit distance or installation, recurrence relation, and termination. In installation, we have to use d of I comma 0 is equal to I and d of 0 comma j is equal to 0. Recurrence relation for each I is equal to 1 to m and for each I is equal j is equal to 1 to n. The minimum edit distance between I comma j is d of I minus 1 comma j plus 1 and d of I comma j minus 1 plus 1. D of I minus 1 comma j minus 1 plus of we have to use here 2 comma 0. If 2 is used, then the equation is if x comma I not equal to y comma j. If 0 is used in that condition, such as if x of I is equal to y of j. Termination. In termination, d of n comma m is distance. Example, let us consider execution and intention strings. Here is the execution and intention strings. We have to add 0, 1 to 9 here and 0, 1 to 9 here. We have to compare I and E. I and E is, we have to find the minimum edit distance between execution and intention. Let us compare the letters I and E. I and E is not same letters, so we have to perform either substitution, deletion, or insertion operation. Here 1, 0, 1. 0 is the smallest number, so we have to add plus 1 to the 0. That let the number becomes 1. And the comparison between I and X. I and X are the two different letters, so we have to perform deletion, insertion, and execution operations. So then we compare the numbers like 2, 1, 1. 1 is the smallest number, so we have to perform substitution operation. We have to add plus 1 to the 1. The number becomes 2. Comparison between I and E. I and E is the two different letters, so we have to perform insertion, deletion, substitution operation. We have to compare 3 to 2 numbers. Here 2 is the smallest number, so we have to add plus 1 to the 2. The number becomes 3. Comparison between I and C. I and C are different letters, so we have to perform the operation and that the number becomes 4. Comparison between I and U, the number becomes 5. Comparison between I and T, the number becomes 6. Comparison between I and I are the same letters, so we have to use a deletion operation. So the number becomes 6. Comparison between I and O, then the number becomes 7. And comparison between I and N, the number becomes 8. Now the compare the letters between N and E. We have to compare the numbers for this N and E, 1 and 2. 1 is the smallest number, so we have to add +1 to that number. It will become 2 here. Compare between N and X, the number become 2. Compare between N and E, the number become 3. Compare between N and C, the number become 4. Comparison between N and U, the number will be 5. Comparison between N and T, the number will be 6. Comparison between N and I, the number will be 7. Comparison between N and O, the number will be 7. Here N and N are the same letters, so we have to perform deletion operation. Then the number becomes 7. Comparison between T and E, the number will be 3. Comparison between T and X, the number will be 3. And T and E, the number will be 3. T and C, the number will be 4. T and U, the number will be 5. T and T are the same letter, so we have to perform deletion operation so that the number will be 5. T and I, the number will be 6. T and O, the number will be 7. T and N, the number will be 8. Now compare E and E. E and E are the same elements, so that the number will be 3 here. E and X, the number will be 4. E and E are the same letters, so we have to perform deletion operation. Then the number will become 3. E and C, the number will be 4. E and U, the number will be 5. E and T, the number will be 6. E and I, the number will be 6. E and O, the number will be 6. E and N, the number will be 7. Now we have to compare letter N with the execution. E and E, the number will be 4. E and X, the number will be 4. E and E, the number will be 4. E and C, the number will be 4. N and U, the number will be 5. N and T, the number will be 6. N and I, the number will be 7. N and O, the number will be 7. Here N and N are same letter, so we have to perform deletion operation so that the number will be 6. Here we have to compare the letter T with the execution. T and E, the number will be 5. T and X, the number will be 5. T and E, the number will be 5. T and C, the number will be 5. T and U, the number will be 5. T and T are same letter, so we have to perform a deletion operation. So we go with the diagonal number like 5. T and I, the number will be 6. T and O, the number will be 7. T and N, the number will be 7. So we have to next we have to compare I with the execution. I and E, the number will be 6. I and X, the number will be 6. I and E, the number will be 6. I and C, the number will be 6. I and U, the number will be 6. I and T, the number will be 6. I and I are same number, same letters. So we have to perform deletion operation. So the diagonal number will be written 5. I and O, the number will be 6. I and N, the number will be 7. Next, we have to compare O with the execution. O and E, the number will be 7. O and X, the number will be 7. O and E, the number will be 7. O and C, the number will be 7 because in 6, 6, 7, 6 is the smallest element. We have to insert the element with +1. So it will become 7. O and U, the number will be 7 because here 6, 6, 7, 6 is the smallest number. So we have to insert +1 with that 6, it will become 7. O and T. O and T are a different letters. So we have to perform an insert operation here. It will become 7 because 6 is the smallest number here. So we have to add +1. It will become 7. O and I are the different letters. So we have to perform either insertion or substitution. We have to perform insertion operation because 5 is the smallest element. Those 5, 6, and 7. So we have to add +1 with that 5. It will become 6. O and O are the same letters. So we have to perform a deletion operation. Then the number will be 5. And O and N are different numbers. So we have to perform either insertion or substitution in this 7, 6, and 5. 5 is the smallest element. We have to substitute the number. So 5 + 1, 6. Now we have to compare the letter with the execution string. Here N and E are now comparison between N and E. N and E are two different letters. So we have to perform insertion or substitution. By comparing the numbers 7, 8, and 9, 7 is the smallest number. So we have to insert 7 with number 1. So it will become 8. Comparison between N and X. N and X are two different letters. So we have to perform insertion or substitution. Here 7, 8, and 8. 7 is the smallest number. So we have to perform insertion operation and add +1 to that 7. It will become 8. The comparison between N and E. N and E are two different letters. So we have to perform either substitution or insertion operation by comparing those numbers 7, 7, and 8. 7 is the smallest number. So we have to add +1 with that 7. It will become 8. Comparison between N and C. N and C are two different letters. So we have to perform insertion and substitution operation by comparing those numbers 7, 7, and 8. 7 is the smallest number. So we have to add +1 with that 7. It will become 8. Comparison between N and U. N and U are two different letters. So we have to perform insertion or substitution operation by comparing numbers like 7, 7, and 8. In those 7, 7, and 8, 7 is the smallest number. So we have to add +1 with that 7. So it will become 8. Comparison between N and T. N and T are two different letters. So we have to perform the operation and that number will become 8. Comparison between N and I. N and I are two different letters, so we have to perform either substitution or insertion operation, so that the number will become 7 here. And comparison between N and O. N and O are also two different letters, so we have to perform operations by comparing 5, 6, and 7. In those 5, 6, and 7, 5 is the smallest number, so we have to insert +1 with that 5, so it will become 6. Here N and N are the same letters, so we have to perform a deletion operation such so that the number will be 5 here. Minimum edit distance between the two strings are 5. Let's go back to the peak bitting. This is the overall problem. There are final output are minimum edit distance is 5, and the operations performed in that to find the minimum edit distance are 3 substitutions and 2 insertions. Thank you.